Hello, everyone. Welcome to the analysis meeting on March 22nd, 2022. On the agenda, we'll have our usual check-in and then kind of a short meeting today. I'll talk about our weekly schedule just as a reminder for our new members. Then an update regarding the Open Rocket file and something I found out yesterday. Then just an overall update on Zenith / our MMM plans. And then closing it out with, I guess, a modified file of Zenith and the FEA that we have to run. I guess Arturo and Omar know about that. And then questions at the end. So checking, how was your spring break? Is there any progress made on tasks yesterday, or who showed up to the lab? And then just thoughts on your personal workload for the rest of the semester.
I can go first. Spring break was pretty good. I went to the rodeo, saw a couple movies, and no life Elden Rings, which was pretty much my spring break. Yesterday at the lab, it was just me, Arturo, and Will, and Gustavo showed up. So we talked a lot about kind of our tasks that we've been kind of working on, which I guess we can talk more about later. Thoughts on workload. A big exam this Thursday, but I think after that should be good until finals.
Nice. Yeah, I'm sitting next to Carlos and he's grinding for that test. All right. Worked on a few CFD sims with CAD models. Gustavo recommended adding small fillets to the parts to get a more realistic simulation. Good point. Batman too. Batman is really good. I guess I will go. My spring break was pretty good. I spent a lot of time with family, so it was good to catch up with them. No task progress from yesterday, but I'll talk about the Open Rocket kind of error that I found. And then my workload for the rest of the semester. I guess I'll be handing off treasurer duties relatively soon to Arturo. So that'll kind of be off my chest. But yeah, still going to be pretty busy, but we'll always have time for my favorite sub team. Pablo said didn't even get a grade because your CS class has a project due on Tuesday, and then I had to do a couple quizzes for a math class. Nice. Oh, replace break. Yeah, that's tough. I hate spring break. You should not be allowed to assign stuff and have to work on stuff, or like test the first week back. That should also be banned. You want to share?
Yeah, I'll go. So spring break, allergies really kicked in. Got sick for like 4 days. That kind of sucked. And then let's see, test progress. I think Omar said we'll talk a little bit more about that later, so I'll save it. And then workload for the rest of the semester. I mean, I don't know. I mean, I'm taking quite a few classes, but up until now, I've managed to balance everything, so it should be okay.
That's nice. Sounds good. Move on to our first item. Just a quick reminder about our weekly schedule. So our lab times are Monday, 11 a.m. to 1 p.m. and Wednesday, 6 to 8 p.m. And our online meeting, as you all wonderfully know, Tuesday, 6 to 7, usually ends before that. Okay, the Open Rocket file. So the previous Open Rocket files that we've been developing and tinkering with for our fin analysis and trying to choose that design, they were slightly incorrect. The error was that the nose cone contained weight that was accounted for twice. So in Open Rocket, the actual nose cone weight already contained the epoxy and the eye hook from when we weighed it, but it was also added in as a separate component weight. So it was pretty much just doubling what the actual weight was. So it's now updated, and the new updated file is on the front page of the analysis folder in the drive, and it's titled Zenith R. So how does that affect our apogee and stability? It slightly decreases. We're now down to 27,300 feet roughly. I did add a extra pound to the nose cone just because that's probably what we're going to have to do in the end for stability reasons, to drag that center of gravity more towards the nose cone side. And that's why our stability is 1.6. I think without that pound, we drop down below our 1.5 range, which will not let us fly. So adding some sort of weight to the tip of the nose cone is going to be key for stability and also just being able to fly. That puts our mass at 78.7 pounds, wet mass. So now with Zenith and the MMM, we did get feedback from our second spaceport progress report. So that's not the one we worked on, but the one Irvin submitted, and I guess the ones we have to submit to spaceport just as the year goes on. We were told that the boat tail must have a 6-inch shoulder if it meets any of the following 3 conditions. That's if the motor is thrusting against any part of the boat tail, which is true for us. The fins are being attached to any part of the boat tail, not true for us. I guess we don't count the shoulder. And any part of the motor mount is attached to the boat tail. So there have been 2 options that we've developed. Mainly Gustavo has come up with them and working with structures closely on this. I just titled it Zenith R and Zenith R mod. So I'll go through what both of them look like. Zenith R is what I just showed, the corrected version. That is just extending the boat tail shoulder to 6 inches. I think before it was at a 4-inch shoulder. So the shoulder is, this is kind of the outer portion of the boat tail, and it goes into the lower airframe through a section of it that has a slightly smaller diameter. So it's just like fitting like 2 tubes together. And that is what allows to do it. The nose cone also has a shoulder. It's kind of hard to see on here, but that's how it fits into the top as well. But yeah, so there's the 6-inch boat tail shoulder, and then added the 1 pound to the tip of the nose cone. Same stats as the open rocket I just covered. But the Zenith R mod is mainly what I want to talk about. There is, I wish Gustavo had the CAD for what he's developed for his idea. But this is a different way of tackling the 6-inch shoulder problem, and mainly looking at how are we going to attach the fins. So his idea was to have a fiberglass motor sleeve, which will cover the aluminum motor casing. So you can see there's like a slight outline in red around. That is just what the motor sleeve would be like at a roughly 4-inch inner diameter, I think. And then that would actually connect, or we would find a way to add fillets and pretty much epoxy the fins onto the motor sleeve, and then also onto the boat tail where it makes contact here. So the fin plus the boat tail plus the motor sleeve would all be one part in one assembly. That would work for the entire lower airframe. Yeah, this also has a 6-inch boat tail shoulder, and we keep the motor block, but for added stability and load-bearing components, he wanted to add 3 wooden centering rings. I guess the material is subject to change, but that's what these kind of yellowish rings are, and they'll keep the fins and the motor sleeve all in place. With this one, as you can assume, we are adding a lot of weight to the aft end of the rocket. which is going to pull this center of gravity down. So I had to add a little bit more than a pound, or 1.25 pounds, to the tip of the nose cone just to get us to a desirable stability or a flyable stability of 1.51. This also tanks our apogee by another 1,000 feet roughly. So we're at 26,190 with the wet mass just under 83 pounds. So it is up to, I think, mainly Irvin and Gustavo. I think we're still discussing what's the best course of action moving forward. But analysis, our role within this decision is running an FEA to determine how many bolts that we need for these centering rings. So I guess mainly needing to determine the total load that all the centering rings will take when we land. Not worried too much about launch. I think we all know that they'll survive the forces at launch, but landing will be a lot more drastic. So once we find that load, we then need to, I guess, talk with Gustavo and see how many corresponding bolts are then needed to secure the centering rings to the airframe, which will then impact how many centering rings we may need. This is really just looking at how many bolts are needed to secure the motor sleeve or secure this entire assembly of the fin, the boat tail, and the motor sleeve to the airframe. How can we ensure that it's going to stay in place? And that's what the bolts will do. So I know you guys worked on this in the lab on Monday, but my thought was just rerunning the boat tail FEA, but just with a modified CAD with the added centering rings at different spots. And then just wanted to see where y'all were at, or if you had any questions about what you're doing.
Could you go back to the previous slide?
Yes.
I just had a question. What is the point of having the motor sleeve on top of the motor casing? What's the purpose?
The motor sleeve is serving the purpose of being able to connect the fins to the motor casing. So the way the fins would be attached here is just epoxying from fiberglass to carbon fiber and just securing the fins onto the motor sleeve in that way. Because we'll also have to cut slits in the shoulder of the boat tail for the fins to fit through, right? So that connection will be epoxied, and also the connection when the fin tab hits the motor sleeve as well.
Okay, that makes sense.
Because with this design, we would need to find an MMM solution or a way of securing the fins, because we could epoxy it here with the shoulder, but then we definitely don't want to epoxy it straight to the motor casing.
I see. Yeah, that makes sense. I guess in regard, can you go one slide up really quick? So to start off, yesterday in the lab, I looked at Gustavo's calculator and we had to make a few changes to pretty much the calculations. One was, so the landing load that he got, we had to change that. And we got a pretty significant number. I think started at like 10,000 pounds of force, made a couple of changes because he didn't take into account the upper airframe stuff. He was just taking into account the lower airframe mass. So with that change, it went up to like 20,000 pounds of force, which I think we're getting to the point where I don't know how like accurate that is. And then one other thing is the material of the boat tail, the fact that it's fiberglass. So the material properties that kind of me and Arturo found, I was comparing it to aluminum, like the ones that we usually use. And essentially it was saying that the fiberglass had like a yield strength 10 times stronger than aluminum, which if you saw the picture that Gustavo was showing, how the ones that they made was like super flimsy too, the boat tail. I do not know how accurate it would be. Like, I don't know. I'm hesitant to put this in the report just because I feel like so many other factors play into it. So I don't know how accurate that really is. So I'm hesitant on that.
I think that may be talking about G10 fiberglass or just sheets of fiberglass kind of stacked into maybe like a block, or like kind of how Oberon's fins are
Mhm.
versus like a sheet of aluminum.
I see.
It- yeah, there's no way a um, like fiberglass that's like wound from fibers is like 10 times stronger than aluminum.
Right. The yeah, I guess we could try looking into it more. It's I guess hard to find like an accurate value for like yield strength, tensile strength, all that stuff.
Yeah.
I think that and uh, just the number that we're getting for the landing load, those two things are, I guess, the biggest concern. Um, so, well, I guess besides that, I can come back to that because yesterday we also worked on the centering rings. Um, so I looked up plywood's material properties just because I guess it's the most common. And yeah, ran like just a quick one before I left the lab, just a quick FEA on it to see. I just did 1,000 pounds of force. I didn't do much more than that just to see if it could withstand it. And I don't think that it withstood 1,000 pounds of force on like the inner diameter of the centering rings. But that's just the centering rings themselves. The bolts that we use, they shouldn't shear. But like I said, I haven't looked into it too much. I still have to kind of go over it more because I just kind of ran it quick right before I left. But I guess the solution that I kind of had for that was maybe look into a different type of wood that may be a little stronger than plywood. But yes.
I think also what I was thinking about is if we're gonna have those 3 centering rings, maybe have the very bottom one like kind of close to the boat tail, have that maybe be aluminum as like the MMM was, if it's gonna take more of the impact.
Yeah.
I don't know.
What if we did fiberglass?
Yeah, we could do like a sheet of fiberglass of like same thing fins would. Yeah, they'll be lighter, and yeah, it's gonna drag our CG down. We're gonna add more weight there. Yeah, maybe look into G10 fiberglass. I guess we'll see on Wednesday if you're able to come to lab.
Yeah. But yeah, that's it for me. I don't know if Arturo wanted to add
But
anything.
you might have to go kind of thick if we wanted to like
No, I mean, right now I'm just finishing a study here. Let's see if the bolts shear. Right now I'm just defining the bolts as pin connectors between the sleeve and the wood centering ring. I guess I'll tell you how that turns out later.
I guess I did have a quick question. So the bolts in the centering rings or the machine screws, whatever we use, are they going all the way like through? Like, are they gonna reach the sleeve, or are they gonna like stop right? Okay,
Yeah,
just
they'll-
double checking.
yeah. I mean, unless we need like a giant bolt like that big, but I mean, definitely not going to need something that huge.
I guess I don't know if Gustavo had looked into like the right dimension for it to be like a perfect fit between like the inner diameter of the centering ring and then the outer diameter of the motor sleeve to like keep it like a tight fit, but not too tight to the point where we can't like actually like move it around a little bit.
if you I haven't looked at it like actually like done the numbers on it, but if you Google engineering tolerances, or like slip fits or
Right.
engineering fits, I think that's what it is. It'll give you a table of different diameters that you can use and what the I guess the shaft, which would be the centering ring, versus the diameter of the hole, which would be the center for the airframe. And then at 6 inches, I don't know what that is in in millimeters, but it'll give you like a chart in millimeters and tell you exactly the tolerance that you should.
Yeah. Gotcha.
I think something else to consider with this whole assembly, not really just the FEA, but actual like physical assembly. If we have a system like this, how will it?
Another thing
take
I wanted
place.
to bring up that I was looking at yesterday is the bottom launch load. Like, if there's a boat tail, how the fuck do you put it on?
You just,
What I was thinking,
well, I don't think
might
you'd be
be-
able to have a hard point.
yeah, unless you put the hard point inside the boat tail. Right, so sort of how we did the bolts for the payload.
You just have no way of like securing it because unless you could
Right.
reach through the bottom of the
No, but like the same way we did the payload bolts where we epoxied them together, you could epoxy the hard
Oh,
point
yeah.
to the inside of the boat tail. But the question still stands, does that like break the rule of it has to be a 6-inch coupling if it has a hole going through the coupling?
Yeah, I mean that whole debate or the dilemma of what is a shoulder and if we're like cutting slits through it for the fins, if it still counts as a shoulder. I mean, I don't know. We don't know. We'd have to find that out. But I think for us to focus on this FEA and try and look at what this solution could look like if it is possible, if it's a viable option, then that's what we need to focus on and I guess come up with the answer for. Yeah, that was all I had for today. If you have any questions about anything, I know I didn't talk about any of the other projects we're working on. So if you have any questions about that or just kind of where this fits in the scope of things, then feel free to ask. I know it can be a little confusing.
Yeah, just one more thing. Omar and Gus, do you guys have time anytime this week just to meet and just say exactly what you're thinking of Gustavo? Because I mean, you're throwing out a lot of ideas, but I'm not too sure, like, what you're visualizing.
Yeah, that's my fault. I tend to do that a bit, but I have a CAD that I haven't shared. I haven't shared the CAD with anybody, but I'll share it and then try to give everybody a good example of kind of what's going through my head.
All right, yeah, that'd be perfect. Thanks.
No, we have our lab tomorrow from 6 to 8. I don't know if Arturo or Gustavo or Omar, if you're all planning on.
I do have a meeting at 7 tomorrow, I think.
Okay.
But other than that, I should be able to.
Okay.
I just had a quick question. You guys mentioned hard point. Can you kind of explain exactly what that is?
Yeah, so you can see it somewhat on the Open Rocket, but you see these two, I guess, launch rail, launch buttons, launch lugs. So when we launch, we load the rocket onto a rail. And the way the rocket stays on the rail is through these kind of buttons or points. And they'll slide onto, like if you've seen like T-slot aluminum, it'll just like slide right through that and keep it upright for launch. So those points, well, first you want them as far back on your rocket as possible so that we can ensure as straight of a flight as possible because they'll spend the most time on the rail the further back the points are. But the hard point for Oberon, we just had like a little block of plywood with like a wing T-nut, I guess that's the name, but you would just screw the rail button into that. But with Oberon during assembly, that was like the first step we would take. And it was possible because we could just reach through kind of the opening of the top of the lower airframe and the bottom of the lower airframe, and then just reach with our hands and like screw it in with both of our hands. But it's just to keep this launch button, launch rail, whatever, in place as like on the rocket.
Okay,
I'm
cool.
gonna share my screen real quick.
Go ahead.
and then I'll post the CAD. But this is essentially what's going on. I'm gonna get rid of everything real quick. Okay, so we can you guys hear me?
Yeah, I
Yes.
can hear you.
So we have the boat tail, and the problem is that if we have the boat tail and we add the fins to it, then the fins intersect with the shoulder on the boat tail. So that's really the big issue. How do we get it to where we have a shoulder that's, strong, 6 inches long, and has fins going through it? One way to circumvent that, which is I guess what we're gonna go for from now on, is adding a motor sleeve. So it's not like a sleeve that goes around the motor, and this is what the thrust is going to go through. So when I add the motor right here, you can see that the little lip or the thrust ring on the motor pushes against the red tube and not the boat tail. And to transfer the thrust into the airframe, we're going to add some centering rings, seen right there, and they're going to have some holes on it. And this lip, sorry, this lip of the centering ring is going to be epoxy. So same thing, top and bottom, and then it's just going to be like a strong like mount to the tube. And these holes are going to have bolts that go to the the lower airframe right there that goes over it. So that's really the idea that's going on.
I don't know if you meant to, so you said that lip of the centering ring and you like highlighted the ID of it. You said that's gonna be epoxy?
Yes, that's going to be epoxy to the red tube.
Hmm, okay,
And then
I didn't know it was epoxied on it.
what was that?
Yeah, no, I didn't know that was gonna be epoxied on it too. Okay,
Yeah, and then these holes only go like 75% of the way in. Like they'll stop somewhere like actually, can I do a mid plane of this? So these are let's get rid of these two. This would be the cross section of the thing.
right.
How far in does it go?
I think you said like 75% of the way in.
75%. Okay.
I'll get rid of this. Okay.
So pretty much we can assemble this whole thing and just slide everything in. That's the plan.
That's the idea.
So yeah, exactly.
The motor retention ring at the top, that's what it's called? At the very top? That might not be in the CAD, I'm not sure.
What are you talking about? I think you mean the motor block.
Or the motor block, that's what it's
So
called.
the thing that goes right here.
Yes.
I-
So
that-
that is that,
One thing I assumed, just a random arbitration.
okay, I just want to make sure I understand this. So that motor block, so that stops the motor from like flying up the airframe?
No, it keeps it
Oh,
from falling out of the airframe.
oh,
But-
out.
I guess actually, if we're gonna have these centering rings, it
I don't think
defeats the
you'll need
purpose
the-
of this. No, actually,
No,
it
no,
doesn't.
no, no, it doesn't.
It
It
doesn't.
doesn't. It
That
doesn't.
was yeah, that was a
I saw that.
hot take that was not correct. These centerings hold the tube,
Oh,
easily,
it's
but
the
not the motor
sleeve.
case.
Yeah.
I saw-
Which is this thing. Right, I can make this clear. It's more transparent. So the centering rings hold the tube, not the motor casing.
Mhm.
The motor casing is going to be held in by this block because there's going to be a bolt that goes in from the top that bolts in, and there's going to be no thrust because we'll put in like a little like lip, just so, or sorry, not lip, a little so there's no thrust transfer from the motor through that ring.
So this pretty much takes the job of the motor retaining ring from Omar.
Yes, correct.
Remember, Omar, how I was telling you on Oberon, on the MMM assembly, you have the like motor retaining ring at the very bottom,
Yeah,
and that would go into the rust plate. Yeah, so the motor block just holds
I
it
mean,
from the
I
top
do
instead
have-
of preventing the fallout from.
Zenith here that I can try to. I don't know if everything's catted into this.
Cobra.
Yeah, I guess I just, oh yeah.
So this was a motor retaining ring from before,
Mhm.
and the block at the top is taking that.
So on but the block right of that was taking, not the highlighted part, but I forget the name.
This
That thing, yeah. Is that the motor retaining or the
that's the
Uh,
thrust plate.
the thrust plate? Yeah. So that was taking all the thrust from Oberon's
Yes,
motor, right?
correct.
So I guess in Zenith, what exactly is the part that's going to be taking all the thrust then?
If I get the motor
Hmm.
and I'm gonna slide it down a bit. There's this lip on the motor casing. I don't know the exact size of it. It's like 0.075 or 0.025, something. I don't know. But there's a little lip that will push against this lip right here. Like the edge of the red tube,
Right.
the motor sleeve. That motor sleeve has these rings epoxy to it, right? And those rings are bolted to the airframe.
Okay. So all right, now I see how the centering rings are taking all the thrust and all that. Okay. That makes sense now. Oh, I guess I was just confused on what exactly is happening with the thrust and like what's like actually taking all the load. But yeah, now I see why the centering rings are going to be taking it. Okay. So I guess last question, since the centering rings are taking them, that I forgot the name again. The motor retention ring at the top or that thing at the top. So that's literally taking no thrust at all.
Yeah, the whole idea is we have this bolt right here that is free to move up and down, right?
Mhm.
It's gonna, well, okay, so these are gonna be bolted together. I can't do both at the same time. Can I? Yeah, my thing just starts lagging when I do both of them for some reason. But the whole point is that this bolt is gonna be bolted into this hardware like nut that's at the top of this. And it's gonna be free to basically move up. So if there's like any like bending or anything in the wood, it won't push against the motor block. But if it wants to move down, it can't. If this bolt wants to move down, it can't because it'll be against the block. I don't know if that makes sense.
And that block that's screwed in to the airframe.
Yes, I'm counting the holes, but there will be 4 holes, I believe.
Okay.
Yes.
I have a question.
Yes.
So for the red motor sleeve, why does it have to go all the way up?
It doesn't. I mean, if we wanted this to be here and this to be here, technically we can do that.
That will take away some weight.
It would
Wouldn't that worsen the weight?
also,
we can
it
do
may,
something like this.
it may take away some weight, but it may redistribute some weight or
Yeah, we
take
can-
away the weight that's near the CG. So this would just push the CG back a little more.
Okay.
But also, I think what we have to consider is, will the location of the centering rings, how will that impact the load that it's going to take when it lands? If it's all at the bottom.
Yeah,
Um,
that's what I was thinking too.
I don't know what it is. I don't know why it's saved.
I have to use the restroom, so I can be ready for the meeting.
I have this. I don't know if you guys looked at it yet, but essentially, with a worst case scenario of it hitting the ground and only being able to sink in 1/4 of an inch, which is not much at all, we get 20,000 pound force of landing force, which is significant. So I'm not so much worried about the thrust, which is going to be like the peak thrust is, well, let's say 1,000 pound force or 4,000 newtons.
Wait, acceleration, aren't we the main chute coming down at a constant velocity?
Yes, so it's coming down at a constant velocity of 24.52 feet per second. I just grabbed that from Open Rocket, or actually I grabbed that from the last progress report to the spaceport.
I think
I don't
it was
know.
Carlos.
Yeah, so
Yeah, Carlos.
that's probably the latest number. Might go a little bit higher because of the additional weight, but that's a good enough estimate for now. And it goes into the ground 0.25 inches, which means it has to decelerate at 450 G, basically, which is 20,000 pound force of load, based off the weight that's like the empty weight that's in it.
I have a question now that we have it up. I don't want to like waste too much time for the general meeting, but so for the hardware required, or I guess just a regular question for the centering rings, assuming we're looking at just 20,000 pounds of force for the load, are we going to be like, let's say we only have like 3 centering rings, right? Are we going to be dividing that 20,000 pounds of force by 3, or are we going to have to say each centering ring is going to have to be able to withstand that 20,000, or is it going to like be distributed by how many we have,
I would divide it by 3.
like however many centering rings we have, right?
Won't it be different for each based on where it is in the airplane?
I mean, you can make an assembly from the entire model and just add a force coming from the motor itself.
Yeah.
I think it would be easier than trying to isolate each centering ring and trying to calculate what the force on each would be.
At first, I just said I wanted to see like if there was a centering ring shape where the stresses would concentrate, and then like just basically assume that that's basically what the wood has to withstand, and then whatever amount of centering rings we need to get it below the strength of wood was my initial kind of just quick and dirty way of calculating it. But if you guys want to like take this assembly, put a whole bunch of center rings on it and see how many it takes before you can get to the 20,000 without it failing, then that'll be good too. I'm not really
Yeah.
concerned with how we get the number, just some way of having something to work with.
Okay, so to recap everything, so there's going to be a bolt that goes through the airframe, then the centering rings, and then 3/4 the way through the sleeve, right?
Mm.
And then you said that the centering rings are also going to be epoxy to the sleeve.
Yes, so the rings are epoxy to the sleeve,
Okay.
and that's going to be like one whole unit. So if I could get rid of this. This is just going to be one part. This is going to be our MMM. This
Okay.
slides into the airframe. And once we put the airframe over it, which is, yeah, this thing has, once I add the airframe around it,
Mhm.
it'll, oh my God, this feedback is killing me. I cannot mute. I can, not on Zoom for iOS. It's so stupid. I can put my AirPods into just, and then I'll just do it. Sorry about that. So once the airframe comes over it, there's going to be bolts that go through and attach it at each one right there.
Okay. Okay, yeah, I got it.
Also,
All right.
Chris, if you want to go through and see if we add a whole bunch of bolts to the outside and practically bedazzle the airframe, what is that gonna do for our drag.
What we can also, or what we may end up having to do is way back 2 years, 3 years ago. Yes, attached to the ring unit frame. But they did testing on countersunk versus bulbous.
I don't think we're gonna go counter something. It's pretty fucked. You like bend the wall way too much.
Um, Well, then with bulbous, we can do what we did and just file it down like with Oberon. Remember the like screws that were in line with the,
My concern is if
yes,
Smooth
they would be
versus-
flush.
smooth versus rough paint does such a huge effect, how much does 16 extra screws
Yeah.
their heads do?
What if we airfoil the screws?
They practically are. I mean, we could like fill it in with like hot glue just so they're round. Don't
Tape.
something Randy was mentioning that's pretty funny is that sometimes by making things rougher, you actually make it more efficient because you break up like the boundary layer or something. Rick, you probably can explain that better, but essentially like some airplanes and like their wings will have like little tabs that like induce what's it called, turbulence, because it'll somehow increase the efficiency of the wing. Yeah. So we're just adding diffusers in front of the fins. That's all. It's intentional. 100%.
All right, yeah, I think oh yeah, where I guess if we have a CAD, let's start with the 3 centering rings for the CAD, and then I guess you can send or upload the CAD to the drive, and then Griff, you can look at the CAD and see where the centering rings are, and then each centering ring will have 4 90 degrees apart screws on the outer section.
I mean, you know what's crazy?
Sounds
I
good.
thought that was you over there.
I'll see you in the general meeting. Thank you for coming.
I don't like that.
Peace.